All right. After having dinner, I stopped by the community center of my apartment to record this video. Yeah, I'm gonna take one more video before going to bed. This is going to be short. So in this video, we are going to study welfare properties of Walrasian equilibrium. In the previous video, we studied. We studied a pure exchange economy in which there are two consumers, and we investigated each consumer's economic behavior. So each consumer acts to maximize their utility. So that can be regarded as self-interested behavior in a market. So in that economy, if two consumers act for their own interest and then equilibrium, we investigated how to drive equilibrium allocation and how to drive equilibrium price. So equilibrium allocation is from utility maximization problem, and equilibrium price on the other hand comes from the market clearing condition, right? So in this video, we're going to study welfare properties. So to illustrate the question I'm going to address in this video, let me go to previous slide, slide number 9. So in the previous video, we investigated the allocation determined by market mechanism. And now in this video, we investigate whether that allocation determined by a certain mechanism is efficient or not. Okay, so we're going to make a link to efficiency. Okay, so from equilibrium allocation to efficiency, and that is the most important issue and most important result in economic theory. So this is called a fundamental theorem. Right? So we're going to study two versions of fundamental theorem in this pure exchange economy, very special example of general equilibrium framework. So from in the next week, we're going to extend the insight covered in this video to a little bit more general setting. All right. So now going back to page number 21. So once again, whether equilibrium achieves allocative efficiency, meaning that equilibrium allocation is efficient or not, is a central question in economic theory. All right. And in order to tell whether one allocation is efficient or not, we needed the following notion, the so-called Pareto efficiency. So when it comes to Pareto efficiency, I think you guys have studied this concept in intermediate micro class. But to remind you of that concept, so here is the definition of Pareto efficiency. So we say one allocation X in a pure exchange economy is Pareto efficient if there is no other feasible allocation Y satisfying. So we have two consumers A and B in this 2x2 pure exchange economy. So for both consumers, both consumers weakly prefer allocation Y to X, okay? Because we have this symbol, meaning that allows for indifference between two allocations. Okay? And at least one consumer strictly prefers allocation Y to X. Okay? So if there is no other feasible allocation Y satisfying these two conditions, then we say allocation X is Pareto efficient. Okay? So put another way, Pareto efficiency means we can't improve both consumers better off. We can improve both consumers' welfare at the same time. So there is no other way to make both consumers better off. So if one consumer becomes strictly better off, the other consumers becomes worse off. Okay? If the current situation is like this, then we say it is Pareto efficient. Okay? So here, this diagram shows one example of inefficient allocation. So now we have allocation X here. Okay. Now we demonstrate this allocation X is Pareto inefficient. That is simply because, so we first can draw two indifference curves passing through this allocation X. Okay. They intersect. Thereby, it makes some kind of lens here. So this lens is surrounded by two indifference curves. So this indifference curve is for consumer B. By the way, this indifference curve is for consumer A. Okay, and obviously, if we move in this direction, consumer A is gonna be better off this direction. And in this direction, we can make consumer B better off. And to see why this allocation is not Pareto efficient, think about a one allocation inside the lens. So let's consider this allocation. All right. So with that allocation, so if we move from allocation X to, let me call this allocation Y. So by moving from X to Y, we can make consumer A be better off, because now the new indifference curve passing through allocation Y is above the previous one, is above the previous consumer A's indifference curve. Okay? And at the same time, consumer B's new indifference curve passing through this allocation Y is above his previous one, right? Meaning that two consumers are better off, strictly better off, by moving from allocation X to Y. So by reallocating the distribution of commodities, we can make both consumers better off. So allocation X is not Pareto efficient. And the diagram on the right side shows one example of efficient allocation. So X is Pareto efficient, right? Because in order to make consumer A better off, we have to move this allocation X to this region. Okay. On the other hand, if we want to make consumer B better off, we have to move to this allocation, or this region. We have to move that allocation X to this region. Okay? And they are disjoint, meaning that there is no other way to make both consumers be better off. So allocation X is Pareto efficient. So from this figure, we can infer one important property of Pareto efficient allocation. So at Pareto efficient allocation, two consumers' indifference curves are tangent to each other. Okay? So in terms of marginal rate of substitution, because MRS is the slope of the indifference curve, so for Pareto efficiency, two consumers' marginal rate of substitution should be identical. Okay, so MRS A equal to MRS B, that can be thought of as some condition of Pareto efficiency under a certain condition, because we assume this kind of smooth indifference curves, right? So whenever indifference curves smooth and behave this way, then we have this simple condition for Pareto efficiency. So that is pretty intuitive, because whenever two marginal rate of substitutions are different, so for example, if MRS A, consumer A's MRS is higher than consumer B's MRS. And if we think about the implication of marginal rate of substitution, that can be thought of as a consumer's subjective exchange ratio. So if MRS is a 3, one consumer's MRS is a 3, that means consumer A is willing to exchange two commodities at the ratio of 1 to 3. Okay? He can give up 3 units of good 2 for obtaining 1 additional unit of good 1. Okay? And suppose that MRS B is a 1. Okay? That means consumer B's exchange ratio is 1 to 1. Okay? Then we can easily figure out there is a way to make both consumers better off in this case. All right? And then two more things about this Pareto efficiency. So the set of all efficient allocation is called the Pareto set. All right. For Pareto efficiency, we have so this allocation X should be feasible allocation. Okay, some possible allocation we can obtain from exchange of two people, exchange engaged by two people, right? So that means the set of all Pareto efficient allocations should be inside the box. Okay, so in this figure, so this figure displays one possible set of Pareto set. Sorry, the set of Pareto efficient allocation, namely the Pareto set. Okay, so this Pareto set collects all efficient allocation in this attribute box. Okay, so all points on this set on this curve, the two consumers' marginal rate of substitution are identical. In other words, indifference curves are tangent to each other like this. Okay, and its part, so the one part of Pareto set where both consumers prefer allocation X to his endowment is called the contract curve. So the way to identify the contract curve is, so here is the initial allocation. So before exchange, so it indicates the allocation before the exchange. Okay, and we draw two indifference curves like this. Okay, and now the contract curve indicates this portion. Okay, so any allocation on this curve, okay, any allocation on this curve is a better than initial allocation, initial endowment to both consumers, right? So that is a part of Pareto set in which both consumers prefer to the initial endowment. So by writing a contract for these two consumers, they can reach one of the points on this curve. So this is why we call that contract curve. Okay. So that's just one part of the Pareto set. All right, now welfare properties. So the first, as I explained in the previous videos, there are two welfare theorems, and the first welfare theorem says any Walrasian equilibrium allocation is Pareto efficient. Okay. So whenever we have nice indifference curves, so utility functions, so the preference relation satisfies all the axioms from the completeness to convexity, then we have a nice indifference curve like this. And in this case, this welfare theorem is quite straightforward because one condition of Walrasian equilibrium. So if we remind the first condition of Walrasian equilibrium, that requires both consumers choose bundles so as to maximize their own utility. Okay. So as a consequence, for some necessary condition for utility maximization to consumer A, we need MRSA equals P star, the tangency condition. And for utility maximization for consumer B, we need MRSB is equal to P star. Okay. So combining these two conditions, we have MRSA equals MRSB. That is sufficient for Pareto efficiency whenever indifference curves are well behaved. Okay. So this means Pareto efficiency. So from the first condition of Walrasian equilibrium itself, we know allocation is efficient. And the second condition of Walrasian equilibrium, market clearing condition. So that means we equilibrium allocation is inside the box. So the that feasibility condition is also satisfied. So Walrasian equilibrium allocation is always Pareto efficient. Yeah. So the first theorem provides a formal expression of Adam Smith's invisible hand for comparative market economies, right? So just letting the market work, that leads to Pareto efficient allocation. Yeah. All right. So the we have a nice implication of this first welfare theorem. So the theorem supports laissez-faire policies. That means the government does not have to intervene in the market to improve efficiency. Okay. So if you took principle of microeconomics class, you guys may remember that whenever government implements one policy, like such as a tax policy or monetary policy, the government will face one trade-off between efficiency and equality. Okay, think about a labor income tax. If a labor income tax is levied on people, then even if I work hard, half of my salary is going to be taxed. It's going to be levied as in the name of the tax. That undermines the incentive to work. So it undermines efficiency, right? But at the same time, that income tax can be transferred to people with a low income, then it helps to improve a wealth inequality, right? So whenever such a tax policy has a pros and cons, it may decrease efficiency, but it may increase inequality. So it may alleviate the problem of inequality. So there is some trade-off between efficiency and equality, right? But that this theorem tells us for efficiency analysts, okay, the government does not have to do anything, right? Because the market itself guarantees efficient allocation, of course, under certain conditions, right? So if the government intervenes in the market, has to intervene in the market, that is not for efficiency, okay, but for some equality. So the only possible justification for intervention is gonna be the fulfillment of distributional objectives. So if the government has to intervene in the market, that's just for equality, not for efficiency. Okay. So in that sense, it supports a laissez-faire policies. All right. And the second welfare theorem is the converse of the first welfare theorem. So if the government wants to achieve some efficient allocation, can it be achieved by a comparative market? And the answer is yes, but under some strict condition, more restrictive conditions. Okay, so we need consumer's preference relation is convex. So if preference relation is convex, meaning that indifference curves are convex toward the origin, so it looks like this. Okay. So if a preference relation is convex, any Pareto efficient allocations can be achieved by comparative market by appropriately redistributing wealth in a lump sum fashion. Okay, lump sum fashion means it is not distortionary fashion. So it's a lump sum fashion means you can think of a labor income. Okay, so it does not affect price. Okay, so here is one example of second welfare theorem. Okay, so here is the initial endowment omega. Okay, so if the government let the market work, then the equilibrium allocation is gonna be here. Okay, at this point. Okay, because a market determines price as P star. So with that slope, with that margin line, consumer A will choose this pink point because a indifference curve will be tangent to margin line at this point. And consumer B will choose the pink point as well, right? Because his indifference curve to tangent to his own margin line. So in order to maximize his utility, he's going to choose pink point as well. Okay, so that is the allocation determined by the market as an equilibrium. But if from the government's perspective, this allocation is more like that. So the consumer A consumes way more than consumer B. Okay, so the government may want to achieve some allocation, another efficient allocation in the middle of the box, like X star. And the question is, it can be done by comparative market? The answer is yes. Okay, and how? If the government imposes some tax on consumer A, okay, in lump sum fashion, so price does not change, only his income changes. Okay, so in case of a change in income, we know bottom line will shift down, maintaining the slope. Okay, so the bottom line will shift down like this if the tax was a lump sum fashion, right? Then with this new bottom line, now consumer A and B will choose this target allocation X star as desired, because at this X star, consumer A's utility is maximized, and so is consumer B's utility. All right. So in this way, any efficient allocation on the Pareto set can be achieved by so with the aid of in the comparative market mechanism. Okay, that is the second welfare theorem. So it can be supported as an equilibrium by either transferring wealth this way in a lump sum fashion, okay, or directly transferring endowments from consumer A to consumer B. So that possibility is depicted by this figure. Okay, so initial endowment was right here, and if the consumer A transfer his good, some of his a good one, okay, to consumer B, okay, so that will change the initial endowment point to endowment point omega to omega prime, or can transfer some of his good too. Then it will result in a vertical shift like this. Okay, then either case, now let the market work. Then we have this bottom line. So the desired allocation X star can be achieved. Can be achieved in the same way. All right. So by either transferring wealth or directly transferring endowments, Pareto efficient allocation. So allocation on the Pareto set can be supported in the comparative market. Right? So the second theorem provides a theoretical affirmation for the use of comparative markets in pursuing distributional objectives. Okay. One more important implication is, as I told you, when government attempts to design a new policy, tax or monetary policy, it will face trade-off between efficiency and equality, right? But at least in this comparative market, because by the first welfare theorem, efficiency can be achieved by market, but by the second theorem, equality. So some fair allocation, some allocation in the middle of the box, as long as that is efficient allocation, also can be achieved by market. So at least in the market mechanism, the government does not have to do anything. The only thing the government has to do is transfer wealth from from wealthy people to poor people to achieve that to achieve equality for society. Okay, that is a implication of this welfare theorem. Right? And the last thing in this video is so convex preferences. That condition is quite important for the second theorem. We don't need this condition for the first welfare theorem. So equilibrium leads to efficient allocation. For this result, we don't need convex preferences, but for its converse, we need a convex preferences. To see why, here is one example. All right. So here, consumer A's preferences are not convex. As a result, his indifference curve has a non-convex region like this. Here, it's not convex toward the consumer A's origin, right? And think about the situation where government wants to achieve allocation X star. That is on the Pareto set, so efficient allocation, but it cannot be achieved by comparative market because if you think about the reason, so if we put the market to work, then the market determines price vector like this, as depicted by dotted line. So that is the equilibrium price vector. Okay. So with that vector, consumer B will choose X star. Okay. That is so it satisfies a tangent condition. His indifference curve is tangent to this bottom line. So consumer B will choose X star, but consumer A will not choose this one, because although his indifference curve is tangent to this dotted line, so this bottom line, but consumer A has an incentive to deviate to x1 prime or some other points, because by choosing this point, consumer A can be better off because the new indifference curve passing through this x1 prime, this one is above the previous one. So by choosing x1 prime, consumer 1 will be better off, and that is a feasible affordable allocation for consumer 1 or consumer A, because that is inside the budget set. All right. So even though this is a Pareto efficient allocation, cannot be achieved by market mechanism, if one consumer's preference relation is non-convex, that is a pretty important result of regarding the second welfare theorem. All right. Okay. So this is just a special. So we didn't prove any theorems here. We are going to prove that first and second welfare theorem in a little bit more general environment, and that is just what I discussed in this video are just the special examples of first and second welfare theorem in a specific environment, pure exchange economy model. Right? So we are gonna generalize the insights we covered today next week to a more general setting, to a more general framework. All right, so this is it, and I think I'm done with pure exchange model. And then in the next video, I'm going to talk about the next topic, the second example of general equilibrium in chapter 15, that is Robinson-Crusoe's model. All right, hope you guys enjoyed this video, and see you guys in the next.